6-7. Polygons in the coordinate plane. Number 1. If triangle MLK has vertices M, L, and K, is the triangle scalene, isosceles, or equilateral? So let's take a look at that. To determine if the triangle is scalene, isosceles, or equilateral, we have to find the lengths of each side. So first we're going to find the length of ML. So substituting in the coordinates of M and L into the distance formula, we get -6 squared plus 0 squared, which gives us square root of 36, which is 6. So the length of ML is 6. Finding the length of MK using those coordinates in for x and y, we end up getting -3 squared plus 6 squared, which is square root of 9 plus 36, which equals the square root of 45, which isn't a perfect square, so leave it like that. Now the length of LK, substitute the coordinates of L and K in for x and y, and you'll have the square root of 3 squared plus 6 squared equals the square root of 9 plus 36, which equals the square root of 45. Now, we have 2 out of our 3 sides being equal. That means this triangle is going to be isosceles, so let's choose that. So I'm going to choose isosceles, and that's number 1. Number 2, is Q, R, S, and T below a rectangle? So let's figure it out. The first thing I'm going to do is compare the slopes of opposite sides. If they're the same, then they're parallel. So QR, I'm going to count 1, 2, 3, 4 over 1. So this has a slope of 4. TS, 1, 2, 3, 4 over 1 has a slope of 4. So RQ and TS are parallel. Now I'm going to do this again for RS and QT. So I go down 1, 2 over 1, 2, 3, 4, 5, 6. So -1 over 3 for the slope of RS. Let's check QT and see if it's the same. So we go down 1, 2 over 1, 2, 3, 4, 5, 6. So again, -1 over 3. So RS and QT are parallel to each other. So this is a parallelogram. Now I'm going to have to check and see if the diagonals are equal in length. If they are, it's a rectangle. If they're not, it's not. So I'm going to find the length of RT and QS. So here's the coordinates for R and T. I'm going to substitute those into the distance formula. And simplifying that down, I'll have the square root of -5 squared plus 6 squared, which becomes the square root of 25 plus 36, which equals the square root of 61. Now let's see if the length of QS is the same. So here's the coordinates for Q and S. Substitute that in for x and y in the formula. So simplifying that gives me -7 squared plus -2 squared, which is the square root of 49 plus 4, which gives you the square root of 53. So the lengths are different, so this is not a rectangle. So let's choose our answer. So is this a rectangle? I'm going to say no, because it is a parallelogram, but the diagonals are not congruent. And that's number 2. Going to number 5. Graph and label the triangle with given vertices. Determine whether the triangle is scalene, isosceles, or equilateral, and then tell whether the triangle is a right triangle. Looking at our coordinates is going to be graph C. Now, is that scalene, isosceles, or equilateral? Well, clearly we can see that those are 3 different lengths. So we're going to say that's scalene. Now we've got to determine if it's a right triangle. To do that, we need to find the slopes of each of the sides and see if any pairs of them are opposite reciprocals. If they are, it means that the segments are perpendicular and it would be a right triangle. So let's see. Find the slope of AB. We do change of y over change of x. So substituting in the coordinates of A and B, we end up getting 1/2 for the slope. For the slope of A and C, substitute in the coordinates of AC, and we end up getting a slope of 3 over 2. For the slope of BC, again, change of y over change of x, put in the coordinates of B and C, we get -3 over 2. None of these are opposite reciprocals, so we're going to say it's not a right triangle. So we're going to say no, and that's number 5. Number 6, graph and label the quadrilateral with the given vertices, then determine the most precise name for the quadrilateral. So graphing these coordinates, I'm going to say C is our graph. Now we need to determine the most precise name for the quadrilateral E, F, G, and H. We're looking at our graph. It is not a parallelogram because these two sides are not parallel to each other. It is also not a square because we do not have 4 right angles and all the sides are not the same. It's also not going to be a rectangle because we do not have 4 right angles. So our choices look like they're going to be a kite, which this is not a picture of a kite, but it'll either be a kite, a isosceles trapezoid, or a trapezoid. So to determine whether it's a trapezoid or a isosceles trapezoid, we need to determine if these two lengths are the same. So we got to find the length of EF and GH. So let's do that. So I have to substitute the coordinates of E and F into the distance formula. So doing that, when simplified, gives me -2 squared plus -9 squared, which is the square root of 4 plus 81, which gives me the square root of 85. Now let's see if GH has the same length. If it does, this is an isosceles trapezoid. So substitute the coordinates of G and H in. Simplifying that gives me -2 squared plus 9 squared, which is square root of 4 plus 81, which is the square root of 85. The lengths are the same, so this is an isosceles trapezoid. So let's choose that. So I'm going to choose C, and that's number 6. Number 8, the diagonals of quadrilateral A, B, C, and D intersect at E. A, B, C, D has vertices at A and B. What must the coordinates of C and D be to ensure that A, B, C, D is a parallelogram? So let's go to Desmos and graph these. So here's A and B, and then there's E in the middle. Now, in order for this to be a parallelogram, E has to be the midpoint of the diagonals. So I'm giving this as one of my endpoints, and this is halfway for this diagonal. They would have the same slope going from here to here as from here to the other end. So I'm going to count down 1, and then go over 1, 2, 3, 4, 5, and 6. I counted it that way because every other dash is a whole number. So -1 over 6. So I go down 1 over 1, 2, 3, 4, 5, and 6. That will be point D because we have A, B, C, and D. Now let's find C. Going from A to E, I go down 1, 2, 3, then to the left 1. So I go down 1, 2, 3, to the left 1 at 2, 0. So that would be C. So let's put those in. So C is 2, 0. And D must be 9, 2. And that's number 8.